Starting with questions related to kinematics. Today will be the last class of kinematics question. And in today's class, the questions are more difficult than yesterday. What you have seen over the passage of time, that in kinematics, the formula is straightforward. I'm talking specifically about kinematics 2.0, that is about differentiation integration. If we summarize this chapter, what this chapter is about, that you have an equation for displacement, you differentiate it, you obtain the velocity equation. You differentiate velocity, you get acceleration. As far as differentiation is concerned, if they ask about maximum displacement, derivative of displacement should be equal to 0. You will get a particular value of time. You plug that time in the displacement equation, you get the maximum displacement. If they ask about maximum velocity, you differentiate velocity, make it equal to 0. You find the value of t, plug that value of t back in the velocity equation, you find the maximum velocity. If they ask about maximum acceleration, differentiate acceleration, find time, put back the time in the acceleration equation, you find the maximum acceleration. Now let's talk about integration. Integration is area under the graph. Remember this concept? When you integrate it by plugging in the limits, the lower limit and the upper limit, C does not appear. If they ask for a particular expression, for example, if the acceleration equation is given and they are asking for the velocity equation, then you have to integrate. There will be a plus C, a constant of integration. You would be given some help, you would be given some value. When t is something, velocity is something. When t is 0, velocity is 5. When t is 3, velocity is 10. So you would be given some information to evaluate that constant of integration. Similarly, if velocity equation is given and they're asking for the displacement equation, that means integrate, get the displacement equation plus a constant of integration. Let's call it k. Now this time the question would have said the particle started from O. That means initially the particle was at O. That means when time t is 0, s is 0, so you will be able to find the value of k. Remember, if they ask us the distance between two particular time interval, t is equals to 0 and t is equals to 15, for example, therefore you don't need the displacement equation, you simply need integration, the concept of area under the graph, plug in the limits, and then you get the answer. So now this was a brief summary of what we have done so far, and today in the last class, we will do few more questions on this. Look at the first question, question number 40. A particle travels along a straight line. It starts from rest at point A on the line and comes to rest again 10 seconds later to another point B on the line. That means the journey is for 10 seconds, starting from A, ending at B. There are two velocity equations given for the first 5 seconds, for the next 5 seconds. Show that there is no instantaneous change in acceleration when t is equals to 5. That means differentiate both the velocity equation, take care of all these small zeros, take care of the power and everything. Simple differentiation according to the knowledge of P1. Now plug in t is equals to 5 in both the equation. It so happens that the acceleration coming out to be 0. The acceleration from the second is also coming out to be 0. Since from the first equation, from the second equation, at t is equals to 5, there is no change. It's 0 from the first, 0 from the second. That means there is no instantaneous change in acceleration. For the second part, it's asking for the distance AB. It's not asking for the displacement equation, asking for the distance AB. What should we do? Think. Can I simply integrate the first velocity equation between 0 to 5? Integrate the second velocity equation between 5 and 10? I'll get two values of distances. I'll add them up. I'll get the total distance covered, which is actually the distance AB. Sahi? Let's move on. This one is a tricky question. A tractor travels in a straight line from a point A to a point B. The velocity of tractor is v meter per second at time t seconds after leaving A. The diagram shows an approximate velocity time graph for the motion of the tractor. The graph consists of two straight line segments. Use the graph to find an approximation for the distance AB, for the acceleration of the tractor in the first 400 seconds and the last 400 seconds. Now over here, why does it say approximate? Because the tractor is approximately following a constant acceleration. So the data that we have for constant acceleration, we have plotted it. Later on, that is the next page, it will say that it's following variable acceleration. Velocity in terms of t will be given. So first thing first, for the first 4 marks, what you have to do is that you have to calculate the area under the graph, which is two trapeziums. The first trapezium is in red. The second trapezium is in green. They are exactly congruent trapezium. Find the area of the first and multiply it by 2. As far as the acceleration is concerned, it is the concept of gradient, change in y over change in x. Look at the working. Area of trapezium, half, bracket, sum of parallel sides, bracket closed, multiplied by height. Answer comes out to be 2000, double it up, that is 4000 meters, that is the total distance covered. As far as acceleration is concerned, for the first portion, it is 0.02 meter per second square. For the second portion, it is negative 0.02. Done? Okay, let's move on. For the next part, what does it say? The actual velocity of the tractor is given by v is such and such for 0 till 800. So for the whole journey of 800 seconds, it's following one single equation. Find the values of t for which the actual acceleration of the tractor is given correctly by the approximate velocity time graph. What does it mean? From the velocity equation, you will differentiate and you will get an equation for acceleration in terms of t. And now it's saying find the values of t for which the acceleration from the graph is correct. That means the acceleration from the graph for the first portion is 0.02, for the second portion is negative 0.02. That means the magnitude is 0.02. In reality, it was positive 0.02 and negative 0.02. So you get the acceleration equation. You make it equal to 0.02. One value of time comes out to be 200 seconds. The other value of time comes out to be 600 seconds. So this working was also pretty straightforward. Now the last two parts, they involve a bit of pure math. For the interval 0 till 400, now I'm only focusing on the acceleration portion. The approximate velocity of the tractor is denoted by v1. Express v1 in terms of t. Now, how can I express velocity v1 in terms of t from this diagram? What kind of line is this? Is it a straight line? It's not a curve. It's a straight line. A straight line has an equation of the format y is equals to mx plus c. For the acceleration portion, I can see that the gradient is 0.02 and the y-intercept is 1. So therefore, I can find the equation of this straight line, which comes out to be y is equals to mx plus c, gradient is 0.02, y-intercept is 1. Instead of y, we will write v1. Instead of x, we will write t. So that is the equation of v1. That is v1 in terms of t. That part is done. That's for 1 mark. Now, hence show that v1 minus v is this much. Now, this thing, of course, it's worth much more than 1 mark. The reason why the examiner is giving only 1 mark is that it's kind of tough. You are expected to display your knowledge of pure math, quadratics, completed square form, factorization, taking common, everything for 1 mark. Let's see how it's to. V is equals to 0.04t minus 0.00005 t squared. V1 minus V, 0.02t plus 1 minus that expression. After simplification, this is what you get. A t square term, t term, and a constant. Now, we want it in the completed square form because that's how the equation looks like. A constant on the outside, a linear expression in the inside, a square on the outside, minus a constant. Isn't that the completed square form which you have studied in P1? And mechanics, people give it with P1, people give it with P3. So they can ask anything from P1 that is applicable in mechanics. Now, what is the rule of completing square? The rule of completing square is make sure coefficient of x square, coefficient of t square is 1. That means I'm taking 0.00005 common throughout the equation. So when I take common throughout the equation, you get a t square, you get a 400t, and you get 20,000. Now what? On the inside, first add, then subtract square of half the coefficient of x. Instead of x, it is t. Rewrite the first 3 terms as a perfect square. So therefore, the constant is on the outside, t minus 200 whole square. And then you simplify the constants, which is minus 40,000 plus 20,000. That is minus 20,000. Open up the bracket with that too many zeros and 5. You get exactly the same thing. So 1 mark for making the equation of a line, because there are no half marks in maths. And 1 mark for all this completed square form, which due to shortage of time, if someone wants to skip it, it's better that you skip it. One other desperate attempt could be, get this expression 0.00005 t square minus 0.02 t plus 1, the underlined one, and open up the completed square form. Of course, they both should look the same. That is one desperate attempt. Part C. When we deal with quadratics, when we deal with functions, what else do we deal with? We also deal with domain and range. What is it asking? Basically, they are asking for the domain of 0 till 400. Show that the range of this expression, v1 minus v, it's a new function. The range of this expression is minus 1 till 1. Now, this is a many-to-one function. And in a many-to-one function, what you can do is that you plug in the lower limit, you plug in the upper limit, and you also take care of the turning point. When you plug in the lower limit, you get 1. When you plug in the upper limit, you get minus 1. When you plug in 400, that is the turning point. I think I've written it upside down. The 400 is the upper limit. So the limit, this one, and this is the turning point. Turning point is 200. So this is upper limit, and this is the turning point. So what do you get? What you get is that The highest value is 1 and the lowest value is -1. So you are basically finding the range for the particular domain 0 till 400. Done. Someone could have drawn a graph also. V1 minus V goes on the y-axis, time goes on the x-axis. At 200, for x coordinate of turning point of 200, the y coordinate of turning point is -1. When you plug in 0, you get 1. When you plug in 400, you still get 1. Therefore, the highest value of this function is 1. The lowest value of this function is -1. So function, domain, range, completing square method. So that was the last part was all about. Therefore, the last 3 marks were about functions in quadratic. 1 mark express V1 in terms of t, that was about coordinate geometry. So 4 marks for using pure maths to prove your mechanics question. Let's move on. Look at this question, question 51. A particle P1 moves in a straight line. It starts from rest at A, comes to rest at B. The velocity of particle P, t seconds after leaving A, is v meter per second, where v is given. Find an expression for displacement of P from A in terms of t and k. Now, in this question, they are not asking us to find the distance between 2 points. They are asking us to find an expression for displacement. So you integrate, you obtain a constant of integration. The second line says it starts from rest at A. That means when t is 0, initially velocity is 0 as well as displacement is 0. So when you plug in t is 0, s is 0, what do you get? You get a value for c as 0, and hence you obtain the displacement equation in terms of t, and k is also there. Now, second part, find an expression in terms of t, find an expression for t in terms of k when p is at b. That means after a time of t seconds, velocity is 0 because it's coming to instantaneous rest. So therefore, when t is t, velocity is 0, just plug in the velocity equation, taking common, using common sense. T is 0 and t is 6 over k. Therefore, you obtain t in terms of k. First part was about integration, getting a constant of integration, plugging in the condition and evaluating c. Second part, it's about using the equation as it is. When t is t, v is 0, so you get t in terms of k. Third part, given that the distance AB is 108, that means I can take the velocity equation, I can integrate it between the limit 0 and t and equal it to 108. So therefore, I took the velocity equation and I don't need to integrate it because I already found the velocity equation. I already found the displacement equation. So I can, that integration part is already done. 108 is 2t square minus kt power 4 over 4, and t is equals to 6 over k. So wherever there is t, replace it with 6 over k. Solve it, and then you find the value of k as 1. Done. What is the fourth part? The fourth part is the maximum value of B when the particle is moving from A towards B. We already talked about maximum of anything at the beginning of the lecture. Maximum displacement, velocity equals to 0. Maximum velocity, acceleration is 0. Maximum acceleration, derivative of acceleration is 0. So since it's about asking about the maximum velocity, we will differentiate the velocity equation. We now have the value of k. We will make it equal to 0. We will find the value of time, which in this case comes out to be 0 and 4 seconds. We would discard 0 because that's the beginning of the journey. They are asking about when particle P is traveling from A to B. Therefore, the answer is 4 seconds. Plug in 4 seconds in the velocity equation. You find the value of V as 32 meters per second. अब ये सारे questions में आप गौर से देखें कहानी क्या है. It's about integration. The story is about integration. The story, it's about differentiation. When you integrate it and they're asking for an equation, take care of C. If they're simply asking for the distance, because area under a VT graph is distance covered, you can plug in the values of time, the upper limit and the lower limit, and you can find the distance as it is. Done? Now, let's move on. Let's read the question 52. A particle P starts at the point O and travels in a straight line. At time t seconds after leaving O. Now, from this statement, at time t seconds after leaving O, initially it was at O. So when t is 0, when t is 0, S is 0. And then it says where V is equals to this thing, and V will also be 0, because it does not say it starts from rest, but it does say it starts. So if it starts at the point O, definitely it means it's at rest, and we can double check it. If we plug in time t is equals to 0 in the velocity equation, V also comes out to be 0. The positive value of t for which the acceleration is 0, straightforward. The distance traveled by P before it changes its direction. When does a particle change its direction? Very easy to visualize it, throwing a ball vertically up. We throw a ball vertically up. When does it change its direction? That's a turning point. When the derivative of displacement is 0, when it reaches the maximum height, when it cannot move any further up, it is exhausted, its velocity has become 0, it has come to instantaneous rest. To cut the long story short, the particle will change its direction when velocity will be equal to 0. So now let's look at the working. This is the acceleration equation. Acceleration equal to 0, take common, simplify, use a calculator. So you find the value of t as 8 seconds. When you take common, it's very obvious. Distance traveled before it changes direction, V is 0. Again, take common as much as possible. Variable as well as the numbers. But variables is a must. For example, in this particular scenario, I have taken the variable to be common. I have not taken the constants to be common because I can use a calculator later on. So t comes out to be 12 seconds. Distance travel for the first 12 seconds, integration of the velocity equation between the limits 0 and 12. चलो आगे बढ़ते हैं. A particle P starts to move from a point O and travels in a straight line. The velocity of P is given by such and such. Maximum velocity is 6.4. Now the same question as the previous one. All the questions are carefully selected. There is an underlying message that relates the question. The knowledge obtained from one is used in the other one. Maximum velocity, that means derivative of velocity should be 0. So show that k is this much. Let's look at the first one. Velocity is this much. Keep k on the outside. Why? Because we have learned in pure math, P1 as well as P3, in differentiation, if there is a constant multiplying with the whole bracket, that constant plays no role in differentiation or integration. If it's multiplying with a single term also, for example, 60t squared, so 60 remains as it is. Derivative of t squared would be 2t. So keep the k on the outside. differentiate it with wisdom. That is 120t minus 3t squared. Maximum velocity, acceleration is 0, dv by dt is 0. Take common, k is gone, therefore t comes out to be 40 seconds. Now, when t is 40 seconds, plug it in the velocity equation and plug in the value of v as 6.4. 0.000. Done. Now let's move to the next part. P comes to instantaneous rest at a point A on the line. Find the distance OA. Instantaneous rest. What does it mean? Velocity equals to 0. So when we make the velocity equals to 0, we find a value for time. We can then integrate the velocity expression between time t is equals to 0 and time t is equals to something. We will get the distance. The magnitude of the acceleration at A, we find the acceleration equation, plug in the value of time. If it's positive, it remains positive. If it's negative, it will become positive. The speed of P when it subsequently passes through O. Now this we have to work. First, the second and the third part. We take common, t comes out to be 60 seconds. Integration between the limit, don't forget the constant on the outside. Integration between the limit 0 and 60, that will give you this answer. Acceleration, when t is equals to 60, the absolute value is 0.72. Absolute value means magnitude, absolute value means modulus. अब क्या करेंगे? अब ये करेंगे कि the speed of P when it subsequently passes through O, when a particle starts from O, goes through the whole world, and then comes back to O, what happens? Its distance would be something great. But what is the concept of displacement? The concept of displacement is distance measured from the starting point, from any point. In our case, according to the question, we are measuring it from the starting point. Therefore, it again passes through O. That means displacement is 0. That means I need to find an expression for displacement. Why? Because how will I make it equal to 0? So I read the question again. A particle P starts to move from a point O and travels in a straight line. That means it was at O at the beginning of the journey. Initially, displacement was 0. Initially means time t is equals to 0, s is equals to 0. So this is the condition that you plug in. Those people who are doing P3 and then they are giving M1, for you, this should be a piece of cake. Because what we are solving is a differential equation. For differential equation, we get a general solution. We plug in conditions and we get a particular solution. For the P1 people, what we are trying to do is to try to evaluate C using the two variables, which are T and S. Initially, displacement was 0. T is equals to 0, S is equals to 0. You get the displacement equation. When it passes through O, displacement is 0. Again, common. T comes out to be 80 seconds. What is the velocity of the particle when it passes through O? Plug T is equals to 80 in the velocity equation. You get the answer as 25.6 meters per second. Clear? Okay, another nice question. This is too nice. A particle P moves in a straight line. It starts from rest at a point O and moves towards a point A on the line. During the first 8 seconds, its speed increases to 8 meters per second with constant acceleration. That means during the first 8 seconds, the velocity reaches from 0 to 8 in 8 seconds. That means acceleration is 1. If I draw it on a velocity time graph, it will be a straight line segment. During the next 12 seconds, P speed decreases to 2 with constant deceleration. Now again, the first line had a positive gradient. The second line has a negative gradient. Don't get emotional and don't let it touch the x-axis because it's not coming to rest. From 8 till 2 and the time interval is 12 seconds. P then moves with constant acceleration. Again, a positive gradient for 6 seconds, reaching A with a speed of 6.5 meters per second. That means first 8 seconds, then 12 seconds, then 6 seconds. 8 plus 12, 20 plus 6, 26 seconds is the total journey. And there will be 3 straight line portion. Sketch the VT graph. The displacement of P from O at time t seconds is given by S meters. Shade the region of the VT graph representing S for the value of T, where T lies between 20 and 26. That means the very last portion, where the speed is increasing from 2 till 6.5 in a matter of 6 seconds, shade all the region under the graph. And this is how it looks like. Red line, acceleration. Blue line, deceleration. Purple line, another acceleration. This is a rough sketch. And then I can say that the area for the first 8 seconds is 32 meters. The area for the for the next 12 seconds is 60 meters. That means the distance covered during the first 20 seconds is 92 meters. Now, why do I need this? Because the examiner has very cleverly linked a velocity time graph with variable acceleration. How? Shade the region of the VT graph. That's done. Show that for T lying between 20 and 26, S is something. Now, this is for the first time. What the examiner has done is that the data of a straight line graph will be used to create a displacement time equation. Now, this is a straight portion, the line, the purple line. Can I get the equation of this line? Of course I can. I can find the gradient, y2 minus y1 over x2 minus x1. I can write y is equals to mx plus c. I can plug in a value either 20, 2 or 26, 6.5, and I can find the equation of that line. Have a look. Gradient comes out to be 0.75. Y-intercept comes out to be minus 13. Equation is y is equals to 3/4 x minus 13, but y is not y. Y is v, velocity. X is not x. X is t, t as in time. So you get a velocity time equation based upon the concept of coordinate geometry. And just for fun, just for extra knowledge, that's how equations of motion came into being. They were obtained using the process of integration. Now, what's the last part? I need a displacement equation. That means I need to integrate this velocity equation. I'll integrate it. I'll need some help for finding the constant of integration. What help do I need? I need the help from here. After 20 seconds, the distance covered is 92 meters. That means integrate the velocity equation, obtain a C, plug in the initial condition. When t is 0, S is 92. When you plug in this condition, this one, you obtain C to be 202. Hence, the displacement equation is obtained. That is 0.375 t squared minus 13t plus 202. So a very, very involved question. Question number 60. The graph part, area during the first 20 seconds, the coordinate geometry part, the integration part for finding the constant of integration, and of course, finding the displacement equation. Let's move on. Now, let's look at this question. I think the last question. A vehicle starts from rest at a point O and moves in a straight line. Its speed V is given by such and such. First 60 seconds, this equation is valid. Next 60 seconds, another equation is there. The distance traveled by the vehicle during the first 60 seconds is 540 meters. Find the value of constant K1 and then find K2. Now, in order to find K1, I have two options. I integrate the velocity equation between the limits 0 and 60 and equal it to 540. That's one approach. Second approach, I find a displacement equation, take care of C, because the particle was at O. Initially, the particle was at O when T is 0, S is 0, so I can find the value of C. Then I can plug in T is equals to 60, S is equals to 540, and then I can find the value of K1. Look at both the work. Simple integration. No constant of integration because the limits are being plugged. Simplify. You find the value of K1 is half. Alternative method. Constant of integration C. T is 0, S is 0. It so happens that C comes out to be 0. This is the displacement equation. And when T is 60, S is 540, use a calculator, you find the value of K1. So both methods are applicable in the scenario. Now, what does it say? Show that K2 is 12 root 60. Now, this time I cannot get away with integration. The reason being, I don't have the time interval for the second. I don't have the distance given. But what happens is that the time value 60 is part of the first as well as part of the second. Velocity obtained at time t is equals to 60 from the first equation should equal the velocity obtained from the second equation. So therefore, when time t is equals to 60, you plug in the first equation, time t is equals to 60, you plug in the second equation. You equate both of them, and then K2 comes out to be 12 square root 60. Third part. Find an expression for the, in terms of t, for the total distance traveled when t is greater than or equal to 60. That means I'll integrate the second equation. I already have the condition in order to evaluate C for this part. What condition is that? When t is equals to 60, S is 540. Simple. And then the last part, find the speed of the vehicle when it has traveled a total distance of 1260 meters. When it has traveled a total distance of 1260 meters, that's not happening during the first 60 seconds. Because during the first 60 seconds, the total distance is 540. That means it's happening during the second equation, the second displacement equation. Let's look at the working. S is equals to 12 root 60, t raised to power of minus half dt. We are integrating this. We get a constant of integration. We plug in the conditions. When t is this, S is this, that's called the condition. We find the value of C as minus 900. So S is equals to 24 root 60t. That's another way of writing it. I can take the square root common, 24 root 60t minus 900. That's the other question. This is perfectly right. The other one is perfectly right. Now, what about the fourth part? The fourth part is you equate 1260 to this thing, minus 900. You make t the subject, t comes out to be 135 seconds, and just like before, they're asking the velocity at this instant. So velocity comes out to be 8 meters per second. This was what was being asked, and that's how it's to be done. So now that is the end of kinematics. And in tomorrow's class, what we're going to start is the concept of linear momentum.